Hi again, Will. Today we're going to show you, after the class you had, we taught you what the different meanings of the different parameters were. Now we're going to show you how to do each parameter on a patient to be successful. Now, the various parameters that you can do at the bedside, probably the easiest is called the peak expiratory flow rate. That involves using a peak flow meter. You instruct the patient to take a deep breath in as much as they can, and they forcefully exhale as fast as they can through the peak flow meter. That will give us a number, and that's their peak expiratory flow rate. This parameter is usually done with like asthma patients. They're given this at home, and they monitor it on a daily basis, usually at the same time of the day. And it gives them an idea whether they're starting to run into problems. And again, in the class, I explained to you what the green, yellow, and red zones were. And those were the zones they're taught what to do with. So we're going to show you how to do each one of those. Now, keep in mind, there's probably 50 different peak expiratory flow meters out there on the market. No matter what they look like, doesn't matter, they're all done the exact same way. So if you're handed one in clinics that you're not familiar with, keep in mind that in order to do a peak flow, you do it the same way no matter what the peak flow meter is. Another bedside parameter we're going to do is minute ventilation, tidal volume, vital capacity. These are all done through what's called a respirometer. You're probably familiar with what's called a right respirometer. Again, just like the peak flow meter, there's several ones on the market. They all look different, but they're all pretty much done the exact same way. And I'm going to show you how to do each one of those parameters. Again, minute ventilation is just what it says. You're going to have the patient breathe through the respirometer for 1 minute, counting their breaths, and then you take that number and you divide by their respiratory rate, and you get what's called their tidal volume. So that's very, very important, especially when it comes to weaning a patient off a mechanical ventilator to make sure they're able to come off the mechanical ventilator. Again, I'm going to show you how to do that procedure. Another procedure that we do, also using a respirometer, is a slow vital capacity. And I stress slow vital capacity because the respirometers have veins in them and they're very fragile. If you blow forcefully through these, you will break them. So when you have the patient do that, it's very important they understand that when they blow out, they're going to blow out nice and slow and steady, but not fast, because you don't want them breaking your equipment. And I'm going to show you how to do that. Again, that's also a weaning parameter. Tells how deep a breath a patient can take in. And the last one we're going to go over is what's called a NIF. And another name for that is MIP. So NIF is NIF, stands for negative inspiratory force. MIP, same thing, maximal inspiratory pressure. They're all done the same way. NIF's important. You'll probably get real familiar with the number minus 20. When you breathe in, you're going to get a negative number, and the number we're looking for tells us whether that patient's going to be able to clear their secretions if you take them, the endo tube, out of their lungs and have them breathe on their own. Again, minus 20 is the minimum amount that we would look for to say, okay, if we take that tube out, the patient's going to be able to clear their secretions. Again, several different ones on the market, but they're still all done the same way. So I'm going to show you, give you an idea of what each one of them look like, and then we're going to proceed with showing you how to do the test. Now, the first thing we're going to go over is the peak expiratory flow meter. Again, this is one that you'll see. Again, you see the scale here, and you see the red thing here, okay? This moves, so when I blow out, this red thing moves up, and then I can read the scale, and that's your peak expiratory flow. Now, if you can really see that real well, okay, try to steady it. It's not real good. But again, this is one example. This also has a handle on it, which is nice. You use that to blow through, pack it up, and like I say, they usually use it at home. Another one that you may see out on the market is similar to this, same basic thing. You blow through this end here, and you have a little yellow disc that moves up. Again, you read the number that's on the side, and that tells you your peak flow. Now, a third one that we have is this one. Again, it comes like this. You unfold it, it has a handle. Again, this has the scales on either side, and it has the red here that moves when you blow. So you put that all the way to the bottom, have the patient hold on to it, blow as fast as they can through that, and then you're going to measure what peak flow it is. And again, as you can see, 3 different ones, but they're all done the exact same way. Now, as far as respirometers is concerned, here's one idea of what a respirometer looks like. This is just one of them. Okay, and what you see here, the red needle, when it goes around, goes in points. So you'll see 0.1, 0.2, 0.3, 0.4, all the way through, and then the numbers in between. The little scale up here that looks like a clock also has a needle that moves around, and for each number on it, it stands for liters. So when this needle here goes all the way around once, the small needle will go to 1. That means the patient has exhaled 1 liter or have 1 liter a minute ventilation. And we're going to show you how to read each one of these. They're all read the exact same way. Okay, this is one example of a respirometer. This is another example of a respirometer. It's nice and bright. Again, it has 2 needles. You have the numbers 0.1, 0.2 all the way through. The small needle, again, when it moves around once, the big needle will move over 1, meaning 1 liter per minute. And again, I'm going to show you how to read it. This is another kind. This is a smaller model, essentially the exact same thing. Again, 2 needles. They're read the same way. I think you're getting the idea that there's a lot of them out on the market, but they're all the same. And this is the 4th one that I found. Again, you got the needle up here, and you got another needle that goes around. All right, now, when you look at these, every one of them, on the side, right here, has an on-off button. And that just toggles over or on and off. So when you're ready to do the test, you're going to put it to on mode. On this side, there's a little button. That button's like a stopwatch button. If you're trying to see how fast somebody can run and you press it and it stops, essentially the same thing. It's used to reset the numbers. Let me show you. Okay, you see the needle's kind of in the middle there. When I press this button here, it takes it back to 0 and resets it. So this resets it, but it also will stop it. So you're going to stop it, look at your number. If you need to do it again, you're going to reset it and do it again. Again, as you can see, there's 4 different ones, and they're all done the exact same way, which I'm going to show you how to do. Now, last but not least, this is an example of a NIF meter. Again, there are several of these on the market. This is the only one I could find, but this is what it looks like. And you see there's a little red needle on that, and there's also a black needle. Now what it is, you have the patient suck in as fast as they can. I'm going to do it once. Well, I don't have it connected. Okay. You have them suck in as fast as they can. The black needle pushes the red needle down, okay? And then I would look and I would read the red needle, and that's going to tell me what their NIF is. Again, what did I say? You want minus 20. That is the minimum amount in order to extubate a patient so they are able to clear their secretions. I'm going to keep telling you that number until it's beat in your head, because you're going to get it on many tests and also your TMZ exams, and when you're in clinics and when you're in real life you're doing parameters. Now, First thing we're going to do is the peak expiratory flow meter. Again, it's usually used to monitor the peak flows on asthma patients. As I told in class, I'm not going to go over it again. You have a green, yellow, and red zone that's based on their best peak flow. Again, all these peak flow meters generally come with a graph. And you can say, okay, you're female, you're 5'2", you're 20 years old, and you go down and it gives you a number. That is a predicted. So let's say you're 20 years old, 5'2", female, and if I go over, it's going to say 450. Again, I'm just pulling that out of the air, but that is what I would use as your predicted. So if I have them blow out as hard and fast as they can, and I predict they're going to get 450 milliliters and they're only able to get 225, I just divide 225 by the 450, I'm going to get 50%. So that means their peak flow is 50% of predicted. Now, once we send them home, as I explained in class, they're going to go by their best peak flow, because everybody's different. That's just a predicted. For a person I send home, their best peak flow might be only 350, and they're never going to get 450 mLs for a peak flow, or liters per second for a peak flow. Now, to do one of these, again, the red thing, I'm going to move all the way down to 0. Don't pay attention to these things down here. These are your red, green, and yellow zones, which you set later, okay? So don't pay any attention to that. What I do is have the patient breathe in to total lung capacity, which means as much air as they can. And again, you really have to coach the patient. You want to yell at them and have them blow as hard and fast as they can. So they'll take a deep breath in, put it in their mouth, and blow as hard as they can. Looks similar to this. Deep breath in. When you do that, again, you see the red needle went from 0 all the way to 500, okay? That's when I would go to my predictors to see what that is. Now, when you do a peak flow, or you do any of these tests, it's best to do it 3 times and get an average, or take the best of 3. Because usually the first time they are practicing, they don't always get it right. So don't just take the first test. You're going to do like 3 tests, take the best of 3, or if they're relatively close, you can take the average of the 3. Again, they're all done the exact same way, just like that. Blow total lung capacity, blow as hard as they can. You get your needle up. You look at that number, okay, and that's what it is. Now, again, the green zones and your yellow zones, you're going to set, again, your green zones, it's 80% above what your predicted is. Your yellow zone is from 50 to 80%. Below 50% is a red zone. Red means danger. That means you're having a real problem with your asthma that day. Maybe you need to contact the doctor. You need more medicines than you have at home. Again, this is for monitoring, mainly for the patient in the home environment. Now, next thing we're going to go over is the respirometer, how to put it together, and what you do it. Now, generally, the respirometer is hooked on an end of an endo tube, okay, which similar to this. It's hooked on right here. This is what it's going to look like. Again, you want the respirometer facing you so you can read the numbers as they're breathing in and out. Now, what it's connected to right here, I'm going to take apart and I'm going to show you what it is. It has, this is a universal parameter. Most hospitals use these typical kinds. It comes like this. If you look, there's a one-way valve on this side, and there's a one-way valve on that side. So what you have to do is you look at your one-way valves, and I still have to look at it. Okay, you want them to breathe in through here, that valve will open. When they exhale, the air will hit it. It's not going to allow it out. It's going to send it out the other side, which goes to your respirometer so you can monitor them. Now, these are what it looks like. These are the two one-way valves that are in there. Now, in order to do a NIF procedure, you have to take these valves out because you don't want them to be able to breathe any air in. You make it so the valves are positioned on either side, so when they suck in, they can't get any air in, and goes to the monitor and they can measure it. Again, it takes a little bit to get used to. Now, to do the test, if I'm doing it with a patient on a ventilator, excuse me one second. If I'm doing it on a patient on a ventilator that has an endo tube or possibly a trach, what you do is you let them breathe for about 1 minute first, kind of get an idea of their breathing pattern. Again, when you first take them off the ventilator, many times patients don't really need to breathe because the ventilator's been doing all their breathing for them. So you have to allow what's called their PCO2 to increase and their PO2 to come down a little bit. That kicks in your wanting to breathe. And after about a minute, when they start breathing, then it's time to do the test. Again, you don't want to just put it on there and just have them breathe directly because your numbers you get will be erroneous. Now, when I do that, again, I'm going to position this so they're breathing in through this valve and out through this valve. It's hooked onto the endo tube. These two ports here are closed off. Those are used for other tests that you can perform. So these are closed off. The outside is attached to your large bore tubing here. Again, I hit the reset button. I'll watch them breathe for a minute. After a minute, I hit reset. And I'm ready to go. Now, when the patient breathes in, I'm going to give you an idea what it looks like here. Again, always use a filter if you're going to play with one of these. Okay, now it's been reset. The number is at 0. So what I'm going to do is breathe for approximately 1 minute. I don't have a watch with me, so I'm just going to approximate it. So again, you want to be watching it as it goes. I'm going to have you guys watch it so you can kind of see how it goes around, okay? So again, been 1 minute, I take it off the patient, attach them back to the ventilator, and then I'm going to look at my numbers. Okay, now if you look at this number here, it's hard to see with the screen. Okay. This little needle that you see up here, right there, is pointing to 5. That means 5 liters. So they have at least 5 liters. Now I look to see where my little needle is at. Again, I know it's coming up backwards there, but the little needle is at 0.45. So what my minute ventilation would be considered 5.45 liters per minute. Now let's say I breathe 10 times per minute during that minute. I would divide the 5.45 by 10, and my tidal volume would be 450. Again, the equation for that is minute ventilation equals frequency times tidal volume for 1 minute. Now, it's very important you're able to manipulate that equation. Again, on your test, it's not going to be straightforward. They're not just going to say their respiratory rate is 10, their tidal volume is this, what's their minute ventilation. They may say, here's your minute ventilation, here's your respiratory rate, what's your tidal volume. They might say, here's your respiratory rate, here's your minute ventilation, what's your tidal volume. So you have to use that equation and mix it around to come up with the various numbers. Again, they often do that on the test, so it's very, very important that you're able to manipulate that. Now, that's a simple minute ventilation. Again, now I'm going to do what's called a slow vital capacity. Again, I'm going to make sure this is on. I'm going to hit this button. It's going to reset to 0. Now with this one, again, it takes a lot of practice with the patient. You got to really explain to them how to do it. You tell the patient they need to breathe in as much air as they can. For you guys, it's considered total lung capacity, and then you're going to have them blow out slowly till they can't get any more air out. And then at that point, the air that's left in your lungs is called the residual volume. You will be learning that in upcoming semesters when you do pulmonary function test, but you might as well get some of the words now. So again, have the patient take in a deep breath in as much as they can. Blow. Take it off. Okay, I can't get any more. Attach them back to the ventilator. Again, I'm going to look at my numbers. And it's hard to read, I know, but I'm going to look at the little number, arrow or needle is at 3. And my other needle is at 0.62. Okay, so my vital capacity is 3.62 liters. Or they may say 3,620 milliliters. Again, you have to know how to do the math. It's very important you can convert milliliters into liters and liters into milliliters because they like to give you various ways of seeing the answers on the test, so you have to be able to do both. Again, that's minute ventilation and vital capacity using a respirometer. Now, the last thing you're going to do is a NIF. Again, this is the only one I could find. Let me get my stuff together here. Again, what I do, if you look at the face, you got the red needle and the black needle. The red needle I set all the way to 0 up against the black needle, like so, okay? I have the patient suck in, take a deep breath in or out, all the way to residual volume, and then suck in as deep as they can and as fast as they can. So all the way out, breathe in, and if you'll see, that red needle moved. My red needle moved to minus 990, essentially, 92. Minus 92 is the number. Again, that's normal, all right? For most people, you can get around that number, but what you're looking for is minus 20. Again, reset the red needle back up to the black needle where it is. Have the patient exhale all the way, suck in. Again, the red needle moves up to the number. Then you put them back on the ventilator, you read the number, and that's what's recorded. So those, again, different ones of these are all connected up differently, but to do the procedure, they're all done the same exact way. That's pretty much for this lecture. Again, I'm here. You can email me with any questions. I'd be happy to go over it with you in the lab. If you need to, of course, using proper precautions, but you'll be getting those next semester in Procedures 1. You'll be shown how to do all of those directly. Right now, we're just kind of teaching you what they are. So that's it for this lecture. Hope it was good. Thank you very much.